Okay, so welcome back to Object-Oriented Programming 1. Today we are talking about inheritance. In German this is Vererbung, so kind of a family tree, but with classes, yeah? So today we are already in the fourth lecture because we had a double lecture last time. And last time we talked a lot about classes, and you also saw some classes already in the practicals today. And today is all about inheritance and polymorphism, what these terms mean. Yeah, you will see today. And then we have a long break of a month for the next lecture, because next week we have a double practicals part. And so with the part of today, inheritance and polymorphism, and the practicals next week where they do all the inheritance stuff again, you are well prepared for the assignment 1. As you have heard in the practicals today, this assignment 1 will be released today after the lecture. Okay, so let's start with a recap. And for this recap, I would recommend to use a pen and a paper because you have to write a bit if you want to participate. This recap is not with Slido. This is just you finding out what's the output. And yeah, it's a lot. So I would suggest take 1 or 2 minutes here to identify what's the output here. We have a superhero class with a constructor or 2 constructors, a copy constructor, a destructor, and then in the main function we are creating superheroes, and there is one function called do nothing, which basically does nothing. So the question here is, what is the output? It will be a bit surprising, to be honest, but let's see how far you can come here.
Yeah, basically the question here is, whenever is a constructor or copy constructor called, in which cases, and when is a destructor called?
Okay, last few seconds, let's say. Of course, you are also allowed to discuss with your colleagues here. Okay, so the output is this one. Let's go through step by step how this could work. So, who had this? Very good. Yeah, okay. At least a few people had it. Great. So, the first call here is constructor CTOR2, which comes from this call here. So, we are creating a superhero with an argument, which means we are calling this constructor here with an argument string, and it sets the name. So this one is called. Okay, the next one is a bit trickier. It's the copy constructor, because we have an existing object assigning to a new object. That's why this copy constructor here is called, and that's the output here, ctor. Next one is even more complicated, because we are calling the function do nothing with our hero2, but we don't take a reference here, which means it is the copy constructor called, because the object is copied, which means just by calling this do nothing function here, we create a copy, and this is then this output here.
So we have a call by value here.
Yeah. Okay, next one is we are returning something. We're returning a superhero, and we are not returning a reference, but we are returning an object, which means, again, a copy constructor is called just by this return function here. And then we have all the constructors, and then we have 4 objects, because this hero A with the variable name age here dies, because it only lives in the scope of this function. So the first destructor is called. And then we have in the main 3 more heroes here, this hero 1, hero 2, hero 3, where we have 3 times again then the destructor. So overall we have 4 superheroes here, and that's why we have 4 destructor calls. Yes?
Is each superhero in the function actually destructed? Because isn't this not even destructed without optimization because of copy elision?
It depends how you compile it, yeah. But if you execute it like this, you will see the output like this. Have you tried it?
No,
I've tried it. And there is, so yeah, of course, I know what you want to say here, but when we, it should be like this, yeah. Of course, there are compile optimizations which checks if it's really necessary to create this object, yeah. But in plain C++ way, it is created and then deleted again. So this is also a function which, yeah, you probably would never write like this. Most likely you will do something here with the superhero, and then it gets definitely created and destructed again. Any other questions to this? Okay, we also had the possibility for you to ask questions also in the past few days, also if you watched the recordings, and we had 2 very interesting questions here which came up. One was if we have to read, for example, a number from a file, and can we just create, for example, a namespace called IO access and put a read function in there, or do we need to put that into a class? So that's kind of a very basic question. Do we need to write everything in a class? My argument is no, of course not. You can, of course, write functions too, which are outside of classes. But if you think of that use case of reading something from a file, most likely it would be, for example, a configuration file, which most likely maybe belongs to, let's say, a game, which most likely then is a class again. So if you just read one number from a file, of course you can just create a method or a function. But in most of the cases in object-oriented programming, this application or this use case of reading something from a file belongs to some kind of higher purpose. And it would also then fit into this, in this case, for example, a game class where there is a read config function, and in this read config function you can read the things from the file and then with this information configure your game object.
So both ways are possible, but for sure depends on the use case, which one is the nicer one to go.
Yeah. Second question was, as shown in one of the last slides last time, why does one have to write class lion colon public animal? So where does this public come from? And we will talk about that in, let's say, 5 minutes, I think.
Yes.
So yeah, please just wait for another few seconds.
Yeah, and the next thing is that we want to have a little recap on inheritance, what we've talked about last time. And in our last lecture, we had the 3 classes with the 3 animals, the lion, the fish, and the turtle class. And we found that the attributes, in this case, the name and the age, as well as at least one of the behaviors, the eat, is similar for all those classes. We had some additional behavior. For the lion, it was run and sleep. For the fish, it was swim. And for the turtle, it was move. But yeah, if we check the code for these 3 classes, we found many duplicated code snippets. So we had, as I mentioned, the same members and also the same method eat. And this is something we can put together in one other class, which we call base class. And our base class is then the animal class, which combines all the members and functionalities that all the specific animals like the lion, the fish, and the turtle have in common. And so we just need to implement the members and also the functionality at one place and only implement the specific behavior in this case, or if we would have additional members for some of the specific classes, then we would just implement in the derived classes. Yeah, and for the terminology, we just say that lion and also fish and turtle is a subclass or a derived class because it is derived from the base class animal. And animal is the base class of lion, fish, and turtle, and this is inheritance and describes an is-a relationship. So a fish is not only a fish, but also an animal. A turtle is not only a turtle, but also an animal. And this is basically the concept of inheritance so far.
Yeah, but we're not finished yet. This is just kind of a start what inheritance is. Today we will have a look how we can implement that in C++.
Yes.
Yeah. So for that we need one more access specifier. So last time we talked about access specifier public and private. And today we also introduce now protected. So let's have a look again at this class here. So we have the class animal as base class with the name and the age and a method called eat. And we have a lion class which is derived from the animal. And we have a run and a sleep method here. When we now create a lion and we call when we call .eat, it works because the lion is derived from animal, so it knows that this methods here and also the attributes can be used also for lions. So this works.
Yeah, so lion inherits all the base functionality from animal.
Yeah. When we now extend that a bit and say in these 2 methods here, I just want to output the name, for example, of the animal in this case, because it's an attribute from the animal, I will end up in a problem in a compiler error. And this says that the name is a private member of animal, because when I don't write it here explicitly, it's everywhere private. which means I cannot access attributes or members, it's the same, from the base class in a derived class when they are private. There are two possible solutions for that. One we already saw last time. Any idea what this could be? Yeah, a getter, yeah, great. So writing here get name and implementing here a get name and returning the name in the public area of the animal would work, yeah. The second one is that we use the keyword protected. Protected means that attributes from derived classes, or in this case from the lion, can also be accessed in derived classes. No, access from in the base class can be derived at, once again.
Okay.
Attributes in the base class can be accessed in derived classes. Okay,
Yes.
now I have it. Yeah.
But not from every other class, just the derived
Just
ones.
from the derived classes. So this now works because they are not private, they are protected. So this protected here means that members cannot be accessed from outside the class, but it can be accessed from all the inherited or derived classes. Kind of the protected makes private accessible for all the derived classes. That's basically it. And this was also the question we showed you before. What does now this public mean here? Yeah, we just used it now, and to be honest, in 99% of your C++ world, you will use this public here. But what does this mean now? It's describing the type of the inheritance again. So you always have class A, then this column, and then a type, public, protected, and private, and then the base class here. And depending on what's here, you can access the specific areas in the base class in certain or in different ways. So if you write public, so as we have already seen, class, lion, column, public, animal, then it works as expected. All the public methods and also attributes are public, accessible public. The protected are protected and the private are private.
So basically everything stays as it is in the base class?
Yeah. If you have, I don't know any use case to be honest, but if you write protected or private here, it just means that you can access the base class in different ways. So for example, public things are protected, protected are protected, and private are private. And if you write private, everything is private, which is basically pretty useless, to be honest, because, yeah, you cannot access the base class.
Yeah.
Yeah. So as I said, in most of the cases, you will just use this one here with public. Okay, that was it already for the access specifier. Any questions regarding this access specifier? Pretty straightforward, to be honest. You just have to remember protected is a new thing which makes private things accessible in the derived classes. Okay.
Okay, then we'll have a deeper look into how objects of inherited or derived classes are created. And therefore, we again look at our example with the animal and a lion, where the lion class is derived from the animal class. And as you can see, we just use the default constructors here, so no specific other constructors are implemented. And the question is now, if we create a lion like this and use the lion afterwards, how is this lion created? And this question is now the question for you. So we prepared this code snippet where you can see those two classes with, yeah, simple constructors that print just something, and the question is, what is the output when we create a lion? So basically the question is, when we create a lion, is just the constructor of the lion called, or just the constructor of animal, or both, and if both, in which order?
Okay, last few seconds. Let's see what you voted for. Great.
Great, yeah.
Wow, okay.
Most of you got it right. So it's first creating an animal and then creating a lion.
Why is this the case?
Yeah, this is because the base class is always created first, and afterwards the constructor of the derived class is called. So whenever we do not have an object of the base class, we cannot create an object of the derived class. So first base class, then derived class.
And it makes sense because we always say that a lion is an animal. So the animal part is created, and then kind of the lion part is set on top of it.
Okay, so now we see two constructors, one in the derived class, one in the base class, without arguments. So what if we want to change, for example, the constructor in the base class, animal, to a constructor that takes a name, and in this case it does the same as before, but at least we have here a parameter in this constructor. What do you think will happen now? Same as before? Different behavior? Any suggestions?
So the only difference is that the animal now has a constructor with an argument.
Yes. What do you think?
Okay, I also tried once with everybody who thinks that it works and the lion is normally created in before, raise your hand. Everybody who thinks that the lion can be created but not the animal can be created, raise your hand. Mm-hmm. Everybody thinks the animal can be created and not the lion, raise your hand. And everybody who thinks it ends up in a compiler error, raise your hand. Oh, yeah, I see a few hands. Any of you want to say why this ends in a compiler error and this is correct? Yeah.
So it has to create the animal first, but we don't give it a name, so it cannot.
Yeah, it has to create the animal first, but we don't hand over a name for the animal, so the constructor cannot be found. And that's why this ends in a compiler error.
Yes. So the compiler now says that class animal can't create an object out of this class because, in this case, we do not have the default constructor anymore, which should or would be necessary, as we have seen in the previous example. So now the first suggestion comes up with just adding the explicit call of the new constructor.
Yeah.
So let's call animal explicitly with a name. But this also does not work, because if we do this inside the constructor of the lion, the compiler now says again, does not work because the animal object has to be created first. So it has to be created before we enter the constructor of the lion. And the solution for this is the initialization list. So if we do it here to explicitly call the constructor of the base class that we want to call, so in this case we just have one with the name, then we can do this here, and afterwards, when we enter the constructor of the derived class, the animal object already is created, and then we can create the lion object.
And this is why the initialization list is so important. And I also mentioned that in the homework that you should be familiar with the initialization list, because if you use these derived classes or inheritance in general, you always need the initialization list to call the constructor of the base class. So in this case, yeah, maybe it would make sense also to hand over the lion the name and then hand it again over to the animal part, but that's just a simple version here. You need to call the constructor of the animal which is present, and as we have seen last time, as soon as we are implementing a constructor in the animal class with an argument, the default constructor with no arguments is gone, so there is no default constructor anymore. So we have to call explicitly the constructor with the name as argument.
Yeah, so this does just work if we have the default constructor in the base class.
Yeah.
Otherwise, we always have to explicitly call the specific constructor of the base class in the initialization list.
That's a very, very important concept. Any questions to this? Because it's kind of the basis of all what's coming next.
Okay, to wrap it up, so the constructor of the base class, so in our case animal, is called first, and then the constructor of the derived class lion is called. Remember, if we do not explicitly call the constructor of the base class in the derived class, then the default constructor would be called, and this is just possible if there is a default constructor. Yeah, and as we've shown in our example, if we call a constructor of the base class in the derived class, it has to be in the initialization list.
Yeah. Now we have seen how objects are created.
Yes.
And there is a counterpart for that, how objects can be removed if they are using inheritance. So again, here we know one part of it. We again have our lion and the animal, but we are adding now a destructor for the animal part and also for the lion class, which then just prints again something out. So the constructor is always creating an animal, creating a lion, and the destructor prints out deleting an animal, deleting a lion. We're again creating our lion object. The question now is, what is the output here? Few seconds for you to think about it. It is the other way around. So we are creating first the animal part and then the lion part. And then we are deleting first the lion part and then the animal part. Which again makes sense because when I set the lion on top of the animal, I just first have to delete the lion to delete the animal again.
So just remember that the lion part can never exist without the animal part.
Yeah. The other way around works. There can be an animal which is not a lion, but there cannot be a lion which is not an animal. So there is this kind of ordering all the time. So the constructor of the base class is first called, then the constructor of the derived class is called. Then you have the lifetime of the object. You can do something with the object, whatever you want. Then the destructor of the derived class is called, and then last, the destructor of the base class is called. I think it's not so hard to think about it, but it can create headache, to be honest.
Yes.
That's the very, very basic version, but in some cases, of course, this is tough because, yeah, maybe you have something in the destructor, maybe you have something in the constructor, and you don't know where to put it, maybe in the base class, in the derived class. When does it delete it? Does it exist already, or does it still exist when you are in the destructor of the base class, and so on? So there are many combinations which can be difficult here, but if you remember this basic ordering, you're on a good way. Yeah.
When you have multiple inherited classes, does it wait for all the other constructors inside of the inherited classes to destruct before it destruct the base one? In other case, does it destruct the base one always in the end?
So you mean if you have multiple derived classes from the same base class?
If you have, for example, lion
Yeah, yeah,
and you have animal on top,
yeah.
does it wait for lion and fish to destruct before animal destruct, or does it destruct, let's say, lion and
Yeah.
animal as of a lion and then fish as a...
Very, very good question. So the question basically is, if I have multiple objects, a lion and a fish, which are both inherited from the same base class, animal, does it wait for every subclass, every derived class to be deleted before the destructor of the base class is called? And this, to be honest, it doesn't work like that, because this ordering just works for one object always. So when I create a fish and when I create a lion, it's two different objects, yeah? And it's always like the lion, for the lion, the constructor of the base class is called, the constructor of the lion is called. Lifetime of the object. Then, for example, we go here, we say we create an animal, or we create an animal, we create the fish part, lifetime of the object. So these are two different objects. Then we can destruct the lion, destruct the animal, because here we have another animal part, yeah? So it's not kind of the class, it's object binding, yeah? So every object has its own animal part. Does it make sense? Any other question? Okay, I think this was again the, let's say, a bit easier part.
Yes.
Now we are coming to this kind of combinations and special cases we have with inheritance, and also how we want to use it, because until now it was always nice to have not duplicated code, but there's no real benefit overall.
Yes. So we've seen functionality implemented in the base class, some implemented in the derived class. Yeah, but now we have some special cases.
Yeah, and we start, so just put this keyword here, virtual, which you might get familiar in the next few slides, but before, just for kind of a motivation for that, without too much explanation, what is the output of this code snippet here? So we talked a lot about creating a lion, but now we are creating an animal. Okay, so as I said, the only difference here is that we create the animal. The question is, what is called first? Is the lion called? Is the lion created? Last few seconds. Okay, great.
Yes.
We are just creating the animal part. Yeah, so,
But there comes up a big question to me now.
yeah.
So if we have a lion and a fish and a turtle class, should we be able to create animal objects?
Yeah, that's maybe a philosophical question. Can we create animals which are not have any specific type? And I would argue it's not possible to create an animal which is not of specific type. But
So there might be use cases where this can make sense, but in our case, I think this should not be possible. So there is a way to prevent that.
yeah,
And I think we talk about this in a few minutes.
yeah, yeah. But first, we want to discuss something a little bit different. And we are creating a zoo again, which has lions and fishes inside. We have, again, our animal class. We stay in our animal class here. We have one method called make noise. And we have two derived classes, a lion and a fish, which now implementing the same method, make noise, and do different things. The lion and the fish obviously both maybe make noises, but do not the same noises. Yeah, so a fish, can make a blop. Lion is a bit louder. What I want to do now is I want to create a list for all my animals in my zoo. And okay, the basic first approach would be that we just create our vector here of lion pointers. Then I create here a lion, and then I push that lion into my vector. And then I have a second vector for fishes, and then I create a fish here, and I push it into my fishes vector, which works if I do it like this. But yeah, it's not very intuitive because I want to have one vector for all of my animals, not only for the lions and the fishes.
Yeah, but I think first we can have a look into what the output would be if we call make noise
if we do it
for
like
all the
this,
lions and then for all the fishes.
Just 2 for loops then, one for the lions, one for the fishes, and if I do it like this, I have, just one element in each vector. So first the lion is executed and then the fish is executed here, so the make noise function. So in this case, it's what we would expect. Not so spectacular, but let's see how we can improve this now. Because as I said before, we want to merge these two vectors into one vector, which contains lions and fishes. What do they have in common? They're animals.
Yeah. So what we can do is, to create a vector of animals.
Yeah.
Or animal pointers.
Create again our lion, creating our fish. Then create an animal vector. Lion and fish are both animals, so this works. I can call pushback on the animal vector and put both inside. And then I iterate over this animal vector and call make noise.
Yeah.
What would be the expected output here? Anybody want to do animal noises? The expected output hopefully would be the same as before. It's first is the lion, so roar, and then loop. Should be the output. The problem is it's generic sound, so the thing what we mentioned here in the animal class. So this does not work as expected. We want to have the output from the lion and from the fish here and not from the animal part of them.
So although the Simba and Nemo are a lion and a fish object, they are treated just as an animal in this case. So because we have an animal vector, in this case, all the lions and fishes within this animal vector are treated just as animal. And this is not what we want.
There is luckily a solution for that. And this is this magic keyword virtual. And if you write virtual here in the base class before the return value and the method name, and we execute this again, by magic, it works now. So it's raw blob. What does this virtual do? This virtual basically says if there is a derived class, check if there is the same function and then use this function there. Not use the one here, use the one in the derived classes. That's basically what this magic virtual says here. So kind of more of a formal definition. When a method is defined as virtual in a base class, it allows derived classes to implement this function again, also called overriding, and ensures the correct function is called based on the object's actual type and not declared type. So even though it's declared as an animal, it checks that there is a derived class which has also the same method implemented, and then this one is used. And this is the concept of polymorphism. In German, it's Vielgesichtigkeit or Vielgestaltigkeit. Yeah, both words are a bit confusing, to be honest.
Let's stay with polymorphism.
Polymorphism just means that the same object can have kind of different viewpoints or faces.
Yeah. And just one remark, if the derived class does not have this function, just the function of the base class is executed.
Any questions to this basic virtual, which is again a very, very important concept? Okay, there is kind of a counterpart of this virtual when we have a look at the lion and the fish, so the derived classes. How can I, as a programmer, see that this make noise from lion and fish is defined in the base class? And there is this keyword called override, which you write after the method name. And this is just, as I said, the counterpart of virtual. Virtual is in the base class, which means there is an implementation, possible implementation in the derived classes. And in the derived classes, you can write override. You don't need to, it works also without it. But this is just for the programmer to have better clarity that this is a function or a method which is already implemented in the base class, and now I want to override it. So basically write it again with slightly different implementation in this subclass here. And this improves the code clarity, so I now know immediately that this is also defined in the base class. And it also checks at the compile time if there is really the same method in the base class, and if not, maybe I have a typo or whatever, then the compiler says, are you sure? Because you are overriding a function which does not exist in the base class. So this is good practice to do this, but it's not needed to implement or to write this override, it's just for clarity for the programmers.
Yeah, and the advantage of override we can see at this example. So if we use, for example, in the derived class fish, a different signature for the method make noise, so in this case we add a parameter, then this is a different signature than in the base class. The compiler says that, now the override here says that there is or there must be the same method with the same signature in the base class, which is not the case. So now we get the compiler error, and now we know there is a mistake. we did a mistake, and now we can, change this code to a
and
valid
in
one.
this example, obviously, it's pretty obvious what's the error. But imagine you having like, I don't know, 20 classes in different files, and you kind of can get confused about that. And sometimes you make a typo switching between the files. And that's why this override helps you a lot to ensure that it's really the same method you overriding. Okay, next quiz, a little bit longer for now. Let's see what you say, what's the output of this code snippet here. Okay, so we have again our animal class, we have our lion class, we have our fish class. The lion and the fish are derived from the animal class. We have constructors implemented with no content inside. We have destructors implemented with a print inside, and in the main we have a vector of animal pointers. We store a new lion, so a lion on the heap and the fish on the heap in this animals vector. And then maybe we do something with it, and afterwards we are iterating over these animal vectors and deleting the animals. Okay, let's see what you've voted for.
Oh,
Okay, yeah. So the output is delete animal, delete animal. So basically, the delete lion, delete animal, delete fish, delete animal, that most of you said is incorrect because there's one important part missing.
yes. So obviously we are skipping the deletion of the derived parts.
Yeah.
But why is that?
So this is again the same code here. We have the animal, the lion, the fish. And we are deleting 2 times only the animal. Any idea why this could happen? It's a bit hidden, to be honest, because it needs a combination of 2 things we discussed today and also last time. The thing is, when we are iterating over the animals here, we are again just deleting the animal part of the lion and the fish. And this also leads to memory leaks.
Yeah. But why is that? Yeah, we have the vector with the animal pointers, although the objects that are stored within the vector are a lion and a fish. But if we iterate through this animal pointer vector, then we delete just the animal part because we call the destructor for animals, which is this one.
If we would have methods inside, what keyword do we need to use to get the lion and the fish method if they're implementing the same?
If you remember the make noise example.
So again, if I have derived classes, Virtual, yeah. So pretty similar here. We have the same problem as before. We need to make sure that the correct type is used. So we just write virtual in the destructor. And this now says that if we are deleting an animal, please have a closer look if it's really just an animal, or maybe there is a derived class of it, and then also delete the derived class part. So in this case, also delete the lion part and the fish part. And if I execute it like this, I have no more memory leaks, because I also delete the lion and the fish, and also the destructor of the lion and the fish part is executed. So virtual is, yeah, a pretty cool thing. Very good question. Does virtual only work if functions have the same name? And in this case, the destructor have a different name. Yes, you're correct. But the destructor is an exception here. It's, in this case, not bound on the name. It's bound on the type. And in this case, the type is the destructor. So in this case, the destructor of the derived classes is called. Yeah, but very, very good question. Never thought about that. Interesting. Any other questions to that? So, kind of a rule of thumb, if you are working with inheritance, always write your destructors virtual, always make them virtual, especially in the base class, because otherwise you will have memory leaks. Okay, so once again, bit back to this polymorphism term. So this means that this object can have many forms or types, yeah? And whenever we call a function or a method and something from the base class, we need to make this virtual, and then the appropriate derived class is function or method is called at runtime. So this is also an interesting thing. It is decided on runtime and not at compile time which class is used. So is it really a fish, or is it just an animal? Is it really a lion or just an animal? Yeah. So there are two different things here. First one is called early binding, and the function is associated with the address at compile time. We see that a lot if we have functions, for example, at compile time. We know which function should be executed when this function is called. And the other thing is late binding or dynamic dispatch. Here at runtime, so really when the program is executed, it is decided which method is taken. So should I really take the method from the base class, or maybe there's a derived class and I call the method from the derived class? And here this is implemented using this virtual keyword. So there are, these two things, as I said, the compile time and the runtime. And the compile time is function overloading, also operator overloading, which we will discuss after Easter. And at runtime, we have this function overriding, which means different implementation in the base classes, or a different implementation in the derived classes than it is in the base class. How does this virtual now works under the hood? Yeah, so it's kind of a magic keyword. Yeah, it just looks into the cloud and sees that it works for whatever reason. It's actually not that complicated. The compiler is, pretty cool here. And as soon as it sees a virtual keyword in the class, it creates a so-called virtual table for this class, also called vtable. And this table just contains the possible methods used here. And then it also creates a pointer and adds it as a member of this class, which is pointing just to this table. So basically, the compiler adds for every class one more member, which then says, okay, there is for this class a vtable, and there you can look if there are derived classes, if there's a base class or whatever. So this, you can also have a look into this if you use something like this in the terminal. Again, I have here a base class. In this case, it's really called base with a speak and a sing method, and a derived class, which is derived from the base class, which also have this speak overwritten, but not the sing. And if I want to see this vtable, you get something like this, a bit of confusing, I have to admit, but it's pretty basic what is in there. We just have function pointers in there, and for the base class, it says, if you call the speak function of this base class, go to this address here, which is just some memory address. And if you also want to call the sing function for the base class, go to this memory address here, whatever in there. If you have a derived object, there is a speak method implemented in the derived. So if you have a derived object, go to this address here. And if you have a derived object and calling the sing method, go to this one here, this address here, which is the same as this one here. That's basically what is done under the hood. So when the speak method of the derived object is called, this vtable then points to the correct method. So when we call it like this, or when we create it like this, we create a new derived object and store it in a base object. So this is the animal, so to speak, and this is our lion. So we have a lion and store it in animal. We can do that. We already did that in a vector. When this is virtual here, it still works if I call b speak. Then it looks into this vtable here and see, okay, there is a function overwritten, so the speak is overwritten. I have to look into this address, which is the derived speak. And when I call this b sing, I go to this address here, which is the address of this sing method of the base class.
Yeah. So this is some nice magic that is going on in the background whenever we use virtual, but it is a very nice concept.
Yeah, but you don't have to implement vtables. So not in this semester. Maybe it's coming in the next semester. I don't know if it's still in the curriculum, but I had to implement it at some point, I think. But yeah, for now it's okay if you just know that there is some magic table which are doing this kind of stuff for you if you use virtual. So virtual overall means that if you want to override a method in a subclass, then please mark this method in the base class virtual. Also with the destructor, if you have a base class, always make the destructor virtual, because otherwise you have the problem that you have memory leaks, because only the base class part of this object will be destroyed and not the destructor of the derived class is called. And for good practice, use this override keyword in the derived class just to explicitly define that I want to override a method from the base class here in the derived class. And if I make a typo or whatever, then the compiler says that this does not match, so I see it immediately. There is one disadvantage here, which is, of course, it takes a bit more runtime cost because you need to create this virtual table, you need to create a pointer, and you need to have this lookup which method to use. But for our purpose, this is neglectable, as I think, because it's just maybe a few milliseconds this take. Okay, Yeah, we had this thing a
Yeah.
few slides before that we don't want to create or don't want to make it possible to create objects of type animal because in real time in real world there is no animal. It always has some specific type.
Yeah, let's say we want to implement it like this, that there can't exist just an animal, but always an object of a specific type. So in our case, a lion, a bear, a fish, a bird, and so on, but never an animal on its own.
Yeah.
And we can do this with so-called abstract classes, or we also call them pure virtual, or we need pure virtual methods for realizing abstract classes. So the last concept for today is that we implement such pure virtual methods, meaning that in our base class, in this case again animal, we set at least one method equals 0. This means that now this whole class will be an abstract class. So this method is called a pure virtual method. And from now on, we cannot create objects from the type animal, which is what we want. So this is necessary to get an abstract class. At least one pure virtual method has to exist. And this also means that in every derived class of this abstract class, so in our example, the lion class is derived, we need to implement this pure virtual method from the base class. So this eat method must be implemented in every derived class. Otherwise, the program would not compile.
Yeah, so in this case, if I don't implement the eat class, the compiler says, hey, you said that this is an abstract class, but you have to implement now this eat method in all the derived classes.
Yes. So the question now, which methods should we define as pure virtual? All the methods that all the derived classes have in common. So in our case, the eat method, all the derived classes have in common, and so we define this eat method as pure virtual method, and then we must implement it in all derived classes, and from now on we can create objects from lion, but not from an animal anymore, which is what we wanted.
Yeah.
Another example would be, imagine a computer game where we want to implement enemies, and for example, enemies always have an attacking method, so they can attack. And this is what every enemy that we want to create have in common. So we define this enemy as an abstract class by defining attack as a pure virtual method. So we write virtual and then set attack to 0. And from this part on, we then have to implement for every derived class this attack method. So for example, we derive zombie from enemy, so we now have a specific type of enemy, so a derived class zombie, and we have to implement attack. So in this case, this enemy attacks by biting. Another one could be a wizard, and this wizard attacks with some magic. And another one, a dragon, for example, attacks with fire. So as you can see, we now have a base class enemy that is pure virtual, has a pure virtual method, so it can't be, so there can't be objects just from the type enemy, but we can have dragons, zombies, and wizards all have specific types of attacks. So this is a nice example why we would want to have abstract classes.
And pretty related to assignment 1, maybe. Are there enemies inside in assignment 1? Not really enemies, but characters or, So you will use it in assignment 1 also, this kind of inheritance. And this makes sense to do when you have one thing in common. In this case, it's the enemies.
Yeah.
But you have different implementations of depending on which type of enemies it is.
Yeah. So basically, just always think about, does it make sense to just have an object of type enemy? If not, then make it as an abstract class by setting at least one method pure virtual. Okay, to wrap it up, for abstract classes, which we can also call interfaces, we have to have at least one method that is set to 0, meaning that it's pure virtual, and then we cannot create objects from this class anymore, and all the subclasses have to implement all the pure virtual methods from the base classes. Yeah, and how do we use it? As we have seen in the examples, we use it for common behavior as, for example, eat for the animals or for the enemies attacking.
And as you said before, interfaces, I think interfaces is the name for it in Java.
Yes.
So this is a concept which is used in many object-oriented programming languages. So this, is pretty common. Okay. So last thing from today, again, if you want to ask a question, it's also for the recording open. If you want to ask some questions about today's lecture, we will read through that and we will answer them next week. So yeah, scan this QR code. It's open until Wednesday, I think, next week. So take your time. If you have questions, then we are happy to answer them next week. Thanks for being here, and see you. Not next week.
Next week there's this double practicals.
So good luck for assignment 1, and we meet each other again after Easter.